Hydrogen fuel cells, they're always talked about as this perfect, clean energy source. They make electricity, and the only thing that comes out is water. It sounds amazing, right? But here's the thing. There's a catch. A really big one, actually. A hidden problem that makes the power coming straight out of a fuel cell pretty much useless all by itself. So, let's get into it.
So here's the big puzzle we need to solve. A fuel cell stack. It absolutely produces electricity, but you can't just plug your car, or anything else for that matter, directly into it. Why not? Well, that raw power is wild. It's untamed. It's just not right for pretty much any modern device. So how in the world do we take that raw potential and turn it into the smooth, refined power that a high-tech electric car needs to run? That is exactly what we're going to break down.
Okay, think about a battery in an electric car. It's like a calm lake. It gives you this smooth, stable, totally predictable voltage. It's clean, reliable power. Now, a fuel cell, it's a whole different beast. It's more like a raging river. The voltage is low, it's super unstable, and it drops like a rock the second you put a load on it. You can think of it like electrical crude oil. It's got a ton of potential, but man, it needs some serious refining before it's any good.
Right, so if the fuel cell's putting out this wild, untamed electricity, we obviously need something to tame it. We need a power conditioner. And this is where the real hero of our story steps onto the stage, the one device that takes all that raw potential and turns it into practical, usable power.
And that hero? It's called the DC to DC converter. And that power refinery analogy we just used, that's exactly what this thing is. It takes that low-voltage, unstable, crude electricity from the fuel cell, and it refines it into the high-grade, stable, high-voltage gasoline that an electric motor or the power grid can actually run on.
So what is this refinery actually doing? Well, it's got three absolutely critical jobs. First off, it has to boost and regulate the voltage. We're talking taking a measly 50 volts and jacking it up to a rock-solid 650 volts. Second, it has to protect the fuel cell itself. It filters out all this damaging electrical noise, or ripple, that can literally destroy the fuel cell over time. And third, it has to manage and direct the flow of power, kind of like a traffic cop, making sure everything goes where it needs to, especially when you've got batteries in the mix.
And trust me, trying to hook up a fuel cell directly is just a recipe for disaster. First, there's a huge voltage mismatch. And with no protection, that current ripple we talked about would just shred the delicate fuel cell membranes. On top of that, fuel cells are kind of sluggish. They can't handle you suddenly stomping on the accelerator. So, without that converter, the whole system would be horribly inefficient, and its lifespan would be cut way, way short.
Okay, so now we get why we need a converter. Let's dig into how they're actually used. We'll start with the most basic setups and work our way up to the really smart, hybrid systems that are powering the fuel cell cars you see on the road today. This is about as basic as it gets, and you'll often see this in things like backup power generators. You've got your fuel cell, our all-important DC to DC converter to boost the voltage, and then whatever's using the power. It's a one-way street. Power only flows out. It works fine for simple stuff, but it's just not flexible enough for something as dynamic as a vehicle.
Right, because for a car that needs to accelerate hard, then brake and recapture energy, we need another player on the team, a battery. And when you add that battery, you get a hybrid system. This is where things get really cool.
Now, engineers have a few different ways they can wire all this stuff together. You've got Topology 1, or T1, which is the simplest. Just wire it all together. But you get terrible control. T2 is better. You put a converter on the fuel cell, which protects it. T3 puts the converter on the battery instead, which is good for peak power, but really stresses out the fuel cell. But the one everyone wants, the gold standard, is T4, where both the fuel cell and the battery get their own dedicated converters. It's complex, sure, but it gives you total control.
And really, all the research points in one direction. The T4 setup gives you complete, independent control over every single part of the system. It lets the fuel cell just hum along at its happiest, most efficient point, while the battery handles all the sudden demands for power, like acceleration, and it can also capture braking energy. Yeah, it's more complicated, but the payoff is huge. You get the absolute best performance, reliability, and lifespan out of the whole system.
So, this all sounds great in theory, but what does it look like inside a car you can actually go out and buy? Let's pop the hood on the Toyota Mirai, because it's a perfect real-world example of all this tech in action.
So, coming straight out of the Mirai's fuel cell stack, what do you get? A low, unstable voltage. We're talking somewhere around 50 volts. That is nowhere near enough power to get a car's electric motor spinning with any real force.
It's that raw, untamed power we've been talking about this whole time.
But then, the DC to DC converter works its magic. It grabs that measly 50 volts and transforms it into a rock-solid, stable 650 volts on the car's main power line. And that massive jump, that's the high-quality, high-octane power the motor needs to give you that smooth, instant acceleration you expect.
And check this out. This is a really fascinating detail when it comes to efficiency. The fuel cell itself, it's only about 50% efficient at turning hydrogen into electricity. But the electronics that manage that power, they're amazing. The inverter is super efficient, but our hero, the DC to DC converter, it's an absolute superstar, running at about 97% efficiency. It does its incredibly important job with almost zero energy loss.
Okay, let's wrap this all up. It's so easy to just focus on the shiny new fuel cell technology, but as we've just seen, it's this little box in the middle, this power conditioner, that actually makes the whole thing work. You just can't overstate its impact.
The DC to DC converter is the absolute linchpin holding the entire system together. It's what enables the system's efficiency, its reliability, its longevity, and the kind of performance we expect from any modern car. It's not just one piece of the puzzle, it affects everything.
Let's be perfectly clear. Without this sophisticated power refinery, the dream of hydrogen power would stay exactly that, a dream. Fuel cell tech would be a cool lab experiment, but it would be totally impractical for cars, trucks, trains, you name it. The DC-DC converter is what makes it all real.
And that brings us to one last really exciting thought. These converters are getting better all the time. They're using new materials like silicon carbide and gallium nitride that let them get smaller and even more efficient. So the question is, as these essential, unsung heroes keep improving, what new frontiers will hydrogen power conquer next? Aviation? Heavy industry? The possibilities are just starting to open up.